Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mail. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Okay, so today we're going to be reviewing for the Chapter 7 test, which is tomorrow. So you'll have from now until, 11:59 p.m. tomorrow night to finish the test. Once you open it, the time starts. Let's see. Anyway, right. Tomorrow we will not be having a regular class meeting. So anyway, just take your test. I had a request for a question. This is from section 7.6, number 21. It says capital H equals capital M cubed divided by CD minus capital Q cubed divided by D. We are to solve for M cubed. So let's clear the fractions. We'll multiply both sides by the LCD, which is CD. So on the left side, we get CDH. On the right side, we get M cubed over CD times CD minus Q cubed over D times CD. So we get CDH equals, here the CD's reduced down and we're left with M cubed minus, here the D's reduced down and we're left with CQ cubed. Then I'm going to add CQ cubed to both sides. And I get, let's see, CDH plus CQ cubed equals M cubed. And there you have it. I'd ask if there's any questions, but there's nobody else here, so obviously there's no questions. Okay, so what I'm going to do now is go back and just do a review of Chapter 7. So let's see. Back in 7.1, we dealt with evaluating expressions. So let's say, for instance, you've got something like this. 2y plus 9 divided by y squared plus 25. And you were to evaluate the expression for y equals -3. So you'd put -3 in the place of y. Everywhere it appears in the fraction, you'd get 2 times -3 plus 9 over -3 squared plus 25, which is -6 plus 9, which is 3. Over 9 plus 25, which is what, 34? So you get 3 over 34, which does not reduce. Then it asks us, it says, find all real numbers for which a rational expression is undefined. And let's say we had something like this, x plus 1 divided by 2x minus 1. Well, when would this thing be undefined? When the denominator is 0. So we're going to take 2x minus 1 and set it equal to 0 to find out what value of x would make this thing undefined. So if x is a half, you'd have what? A half plus 1 over 2 times a half minus 1, which would be 1.5 over 1 minus 1, or 3 halves over 0, which is undefined. So x equals a half would be the value that would make this thing undefined. Okay. Then we had some problems that said simplify. We had a monomial divided by a monomial. Let's say 48 over 16y. We could reduce that down, dividing the top and the bottom by 16. We'd get 3 over 1. So 3 over 1y, but you don't need to put the 1 in front of the y. So just 3 over y. Then we had an expression like this, 4x plus 12 divided by 16. And again, it said simplify. What we don't want to do is try and come in and reduce this or that Doesn't work that way. You can only reduce things that are factors. Oops. So what we have to do is factor both the numerator and the denominator, reduce out the common factors. So our final answer, x plus 3 divided by 4. And let's see. Then we had something like this, where it said simplify. 6 times the quantity d plus 3, all minus 6, over 7 times the quantity d plus 3 minus 7. Don't make the mistake of thinking you can cross out the d plus 3's on the top and the bottom. They aren't factors of the entire numerator and the entire denominator. So what we've got to do, first of all, is distribute 6d plus 18 minus 6, 7d plus 21 minus 7, combine like terms, 6d plus 12, 7d plus 14. Now we can factor a 6 out of the top and a 7 out of the bottom. Now the d plus 2's are both factors of the numerator and the denominator. So now we can reduce it. Okay. Let's see here. A reminder, something like this is equal to -1. A number divided by its opposite reduces down to -1. Okay, how about this one? 81 minus y squared over y squared plus 10y plus 9. And it says simplify. If the expression cannot be simplified, right, does not simplify. In the numerator, I have the difference of 2 squares. In the denominator, we have, let's see, y and y, plus 9 and plus 1. Y plus 9 and 9 plus y are equivalent, so those reduce down to just 1 over 1. So I'm left with 9 minus y over y plus 1. Let's see here. Where did I get that one from? Let's say you've got something like, how about this one? 2y plus 4 times y minus 1 minus 2 all over y minus 1. Again, you can't reduce out the y minus 1's because the y minus 1 in the numerator is not a factor of the entire numerator. So we get 2y plus 4y minus 4 minus 2, which is 6y minus 6 over y minus 1. Now we can factor a 6 out of the numerator. And now y minus 1 in the numerator and the denominator reduce out to a final answer of 6. Let's see. Section 7.2, we dealt with multiplying and dividing rational expressions. So let's say we had something like, how about this one? Z squared plus 4z minus 5 all over 5z minus 5 times 5z divided by z plus 5. Well, I could factor the first numerator and I get z and what, a plus 5 and a minus 1. In the denominator, I could factor out a 5 and I'd get 5 times z minus 1. The numerator and denominator of the second fraction don't reduce at all. So now let's see, the z plus 5's reduced to 1 over 1. The z minus 1's reduced to 1 over 1. The 5 over the 5 reduces to 1 over 1, and I'm left with just z. Okay, let's see, where did I get that from? Okay. How about this one? Let's see. P squared, maybe I should write the number, then I'll know where to go look back. P squared minus P minus 6. This is number 30 out of the textbook. It's not out of WebAssign. Over 3P minus 9 times 2P squared minus 5P minus 3, P squared minus 3P. So factoring everything, I get P minus 3P plus 2, taking out a 3, P minus 3. In the denominator, taking out a P, P minus 3, and I'm going to get 2P and P. And let's see, to get a 5, how about a minus 3 and a plus 1? Would that do it? 6, that will do it. So now, let's see, P minus 3's reduce out. Oh, some more P minus 3's reduce out. And let's see what I'm left with. I'm left with P plus 2 times 2P plus 1 all over 3P. Okay. Let's say you're dividing and you've got 21x over z squared divided by 7x cubed over z to the 5th. Dividing by a fraction is like multiplying by its reciprocal. So we change division into multiplication of the reciprocal. Now we can come back and reduce. Let's see here. Z to the 5th over z squared is z cubed. 21 over 7 is 3 over 1. And x over x cubed is 1 over x squared. So we end up with 3z cubed over x squared. Okay. And let's see here. I think with that, I'm going to just go on to section 7.3, adding and subtracting with like denominators. So if you've got something like y plus 2 over 10z plus y plus 4 over 10z, you get y plus 2 plus y plus 4 over 10z. Adding two fractions with the same denominator, add the numerators over the common denominator. This becomes 2y plus 6 over 10z. I can then factor a 2 out of the numerator. Oops. And then reduce 2 over 10 to 1 over 5. And I end up with y plus 3 over 5z. Okay. Let's see here. Here, let's say this is a 34. You're subtracting two fractions with the same denominator. You have to be careful because you're going to take the numerator of the first one minus the entire numerator of the second one. So you're ultimately going to have to distribute the subtraction sign to both of these terms. Combining like terms, we get that. I could factor a 2 out of the top and a 3 out of the bottom and reduce out common factors and get 2/3. Okay, let's see here. 7.4 was adding and subtracting with unlike denominators. So let's say we've got something like this. 2 over 3a minus 2 plus 5 over 9a squared minus 4. Well, the first denominator doesn't factor further. The second denominator is the difference of two squares. So then our LCD becomes 3a plus 2 times 3a minus 2. So we need to get to here. The second fraction, we don't need to do anything. The first fraction, we need to multiply by 3a plus 2 on top and bottom. Our new numerator becomes 6a plus 4. So now we've got 6a plus 4 plus 5 over the LCD, which is 6a plus 9 over the LCD, which is 3 times 2a plus 3 over 3a plus 2, 3a minus 2. And unfortunately, nothing reduces out. So we can leave it like that, or we could write it, what, 6a plus 9 over 3a plus 2, 3a minus 2. Okay. Let's see here. How about this one? This is number 84. We have 5 over 9x plus 4 over x plus 6. Well, it turns out that the LCD is all of the 9 times the x plus 6. So we've got to multiply the first fraction by x plus 6 over x plus 6, and the second fraction by 9x over 9x. So my new numerator of the first fraction is 5x plus 30, and the second is 36x. So now I've got 5x plus 30 plus 36x over 9x times x plus 6, which is 41x plus 30 over 9x times x plus 6. And there really isn't anything that I can factor out of the numerator to reduce with the denominator. So again, 41x plus 30. I'm just writing it so that it's a little more legible. Not much though. 9x times x plus 6. Okay, simplifying complex fractions. 7.5. If you have a fraction where there's just a single fraction in the numerator divided by a single fraction in the denominator, you can rewrite it like this, and then change division into multiplication of the reciprocal. So then you can come in and reduce and say, take out a 7, and you get 2 over 3. 25, take out a 5, and you get 5 over 3. M to the 6th over m is m to the 5th. So now we've got, what, 10m to the 5th over 9. Okay, but let's say you have a complex fraction where it's more than just a single fraction in the numerator or in the denominator. So you got something like this. 2 over x minus 1/3 all over 2/3 plus x over 5. Find the least common denominator of all the little denominators, which is going to be an x, a 3, and a 5. So 15x. Multiply the numerator and the denominator by the LCD, and you get 2 over x times 15x over 1. The x's reduce out, you get 30 minus 1/3 times 15x over 1. 15 over 3 is 5, and you get what, minus 5x. Okay. Then down here you've got 2/3 times 15x over 1. 15 over 3 is 5, so you get 10x. And then x over 5 times 15x is plus 3x squared. Okay, hang on a second here. Now, let's see. I could factor a 5 out of the top, and I could factor an x out of the bottom. Unfortunately, that doesn't do anything for me, so I'll go back to there. But again, you want to look for factoring to see if you can reduce out a common factor. Okay, let's see here. Let's take a look at 7.6, solving rational equations. So if you have an equation that contains fractions, you can multiply both sides of the equation by the same LCD to reduce out the fractions. So let's say we've got x plus 6 over x plus 4 plus 1 over x squared plus x minus 12 equals 1. Let's see, this is number 43. Okay, so this is the same thing as x plus 6 over x plus 4 plus 1 over, let's see, x plus 4x minus 3 equals 1. So the LCD is x plus 4 times x minus, minus 3. Okay, so I'm going to multiply both sides by the LCD. This times this, the x plus 4s would reduce out, and I'd have x minus 3 times x plus 6. This times this, the x plus 4 and the x minus 3s would both reduce out, and I'd have plus 1. And on the right side, 1 times x plus 4 times x minus 3 is x plus 4 times x minus 3. Okay, so now I've got x squared plus 6x minus 3x minus 18 plus 1 equals x squared minus 3x plus 4x minus 12. Combining like terms, x squared plus 3x minus 17 equals x squared plus x minus 12. Oh, let's move everything to the left side of the equation. So we're going to subtract x squared, we're going to subtract x, and we're going to add 12. So I get 2x minus 5 equals 0. Okay. Then I'm going to add 5 to both sides. 2x equals 5. Divide both sides by 2. X equals 5 halves. Okay. Now, let's take a look at another example. We have, let's see, this is number 83. 4 over y squared minus 4 equals 1 over y minus 2 plus 1 over y plus 2. So factoring all the numerators or denominators as far as we can, we get 4 over y plus 2y minus 2. And these don't factor any further. The LCD is y plus 2 times y minus 2. So we're going to multiply times y plus 2, y minus 2, y plus 2, y minus 2. Over here, the y plus 2 and the y minus 2s are going to cancel out, giving us just 4. Here, the y minus 2s reduce out, giving us y plus 2. And here, the y plus 2s reduce out, giving us y minus 2. So then I've got 4 equals 2y. Divide by 2, and y equals 2. However, if y equals 2 and we plug it in here or here, the denominator becomes 0, so there's no solution. So y equals 2 is an extraneous solution, meaning you found it, but it doesn't work, okay? And in WebAssign, read the directions carefully. It'll ask you, it might say, are there solutions extraneous, or do they work, do they don't work? Just read the directions, okay? Let's take a look at one, solving a formula. 1 over a minus 1 over b equals 1, and we are to solve for b. So I'm going to multiply both sides by the LCD, which is AB. So AB times 1 over A is B. AB times 1 over B is minus A, and I get this. Okay. Trying to solve for B. So what I'm going to do, I'm going to add A to both sides. Subtract AB from both sides, so that I have both terms with b on the same side of the equation. And then I'm going to factor out the b, and then divide by what's left over. So b equals a times over 1 minus a. Okay. Let's see here. All right. Let's see here. 7.7 application problems. Make sure that you know that distance equals rate times time, and that interest equals principal times rate times time. Okay. Let's see. Well, if anybody has any other questions, I guess, let's see here. Well, let's take a look at here's a story problem. It says the sum, oh, how about this one? If a number is added to the numerator of 3/4 and twice as much is added to the denominator, the result is 4/7. Find the number. Okay, so how about if we call the number x? Okay. This is again, this is what, 7.7. So 7.7. Call the number x. If a number is added to the numerator of 3/4 and twice as much is added to the denominator, the result is 4/7. Okay. Find the number. So we could multiply both sides by the LCD, which is 7 times 4 plus 2x, 7 times 4 plus 2x. On the left side, the 4 plus 2x is reduced out, and we have 7 times quantity 3 plus x. On the right side, the 7's reduced out, and we have 4 times the quantity, 4 plus 2x. Distributing, 21 plus 7x equals 16 plus 8x. I'm going to solve for x on the right. So subtracting 7x from both sides, I get 21 equals 16 plus x. Subtract 16 from both sides, and I get x equals 5. Let's make sure. Let's see, 3/4 plus 5 plus 5s would give us, oh, slow down, plus 2 times 5 would give us 8 over 14, which is 4/7. So it checks. Okay. Let's see here. Comparing travel. A plane can fly 300 miles in the same time it takes a car to go 120 miles. If the car travels 90 miles an hour slower than the plane, find the speed of the plane. Okay, so we're talking distance, rate, time here. So we've got plane and car. Distance equals rate times time. Plane can fly 300 miles in the same time it takes a car to go 120 miles. Oh, in the same time, so the times are equal. If the car travels 90 miles per hour slower than the plane, so if the plane is r, the car would be r minus 90. Find the speed of the plane, which is going to be r. So d equals rt, divide both sides by r, d over r equals t. So the time for the plane would be 300 over r. The time for the car would be 120 over r minus 90. But since the times are equal, our equation becomes 300 over r equals 120 over r minus 90. Multiplying both sides by the LCD, which is r times r minus 90, r times r minus 90. On the left side, let's see here, on the left side, the r's reduce out. That doesn't show up very well. And so we're left with 300 times r minus 90. On the right, the r minus 90s cross out, and we're left with 120r. Distributing on the left, 300r minus 27000 equals 120r. Subtract 300r from both sides, and we get negative 27,000 equals negative 180r. Divide both sides by negative 180, and let's see what we get. 27000 divided by 180, we get 150. So 150, what, miles per hour. Did it say for both? It just said find the speed of the plane, 150 miles an hour. Okay. Let's see here. How about this one? Comparing interest rates. 2 bond funds pay interest at rates that differ by 2%. Money invested for 1 year in the first fund earns $315. The same amount invested in the second fund equals $385. Find the lower rate of interest. Okay, so we've got, let's see, first fund and second fund. I equals P times R times T. Two bond funds pay interest at rates that differ by 2%. Money invested for 1 year in the first fund earns $315 interest. The same amount invested in the second fund, the same amount, so the principals are equal, earns $385. Find the lower rate of interest. Okay, so consider this. If they're both put in the account for 1 year and they're the same amount of money, wouldn't the one that makes more interest be the higher interest rate? And it says that the rates differ by 2%. So if this is R, this would be R plus 0.02. Recall from yesterday, I'm converting 2% into a decimal. Okay. Now, the principles are the same. If I equals PRT and we divide both sides by RT, I divided by RT equals P. So this is going to be 315 divided by 1 times R. And this is going to be 385 divided by R plus 0.02 times 1, which is R plus 0.02. So our equation becomes 315 divided by R equals 385 divided by R plus 0.02. The LCD is R times R plus 0.02, R times R plus 0.02. On the left side, the R's cross out. We have 315 times R plus 0.02. On the right, the R plus 0.02 crosses out, and we have 385R. Distributing on the left, 315R plus, let's see, 315 times 0.02 is 6.3 equals 385R. Let's subtract 315R and we get what? 70R. Divide both sides by 70. So R is 6.3 divided by 70, which is 0.09, which is 9%. Now, it said, let's see here, where did this problem come from? Find the lower rate of interest. So that would be 9%. The higher rate would have been what, 11% for the higher? The lower rate is 9%. Okay, well, I'm getting lonesome here all by myself, so I'm going to call it a day. I'm going to stop the recording. Just a reminder, I'll be back at 1:15 with an office hour. Tomorrow, you take your test, and I will see you here on Thursday, if anyone shows up, that is. All right, so take care.